Have you ever wondered how an SSD can save thousands of photos, videos, games, and documents without using any moving parts? Unlike old hard drives that rely on spinning disks, solid-state drives, or SSDs, store everything electronically using tiny memory cells. They're faster, quieter, more durable, and have become the standard storage device in modern computers. In this video, you'll discover exactly how SSDs store your files and why they're so much faster than traditional hard drives. Before we begin, make sure to subscribe to the channel and turn on notifications so you never miss our easy-to-understand technology videos. If you enjoy this video, don't forget to like and share it. Let's get started. To understand how an SSD works, we first need to understand what a file actually is. Whether it's a photo, a game, a movie, or a document, every file is simply a huge collection of binary data. Computers only understand two numbers, 1 and 0. Every image, every song, every website, and every application is converted into millions or even billions of these tiny bits before being stored. The SSD's job is to remember every single one of those bits, even after you shut down your computer. But how does it do that? Inside every SSD are tiny chips called NAND Flash Memory. These chips contain billions of microscopic memory cells. Each memory cell acts like a tiny electronic switch that can hold an electrical charge. If the cell contains a charge, it may represent one value. If it doesn't contain a charge, it represents the other. By checking whether each cell has a charge or not, the SSD can recreate every file you've ever saved. These memory cells are incredibly small. In fact, billions of them can fit onto a chip that's only a few centimeters wide. The cells are organized into pages, and groups of pages form larger units called blocks. Think of it like a library. A page is like a single page in a book. A block is like the entire book. The SSD reads and writes data page by page, but when it needs to erase old information, it must erase an entire block at once. This is one reason SSDs work differently from hard drives. Now let's see what happens when you save a file. Imagine you're saving a vacation photo. First, your operating system sends the data to the SSD controller. The controller is the SSD's brain. It decides exactly where every piece of data should be stored. The controller finds empty memory cells inside the NAND flash chips. Then it stores the photo by placing electrical charges into millions of tiny memory cells according to the file's binary data. Within a fraction of a second, your photo is safely stored and ready to be accessed whenever you need it. Reading the file is even faster. When you open that same photo later, the controller instantly checks the electrical state of those memory cells. It converts the stored bits back into the original image and sends it to your computer, allowing the picture to appear almost instantly. One reason SSDs are so fast is that they have no moving parts. Traditional hard drives use spinning magnetic disks and a mechanical arm that physically moves to find data. Every file requires mechanical movement, which takes time. An SSD has none of these limitations. Everything happens electronically. That means data can be accessed in microseconds instead of milliseconds. This is why your computer boots much faster, games load quicker, and applications open almost instantly when installed on an SSD. But storing data isn't as simple as filling memory cells forever. Eventually, some files get deleted. Here's where SSDs work differently from hard drives. Instead of simply overwriting old data, SSDs must first erase an entire block before writing new information. To manage this efficiently, the SSD controller constantly organizes data in the background. It moves information around, prepares empty blocks, and ensures new files can be written as quickly as possible. Another challenge is that flash memory cells don't last forever. Every memory cell can only be erased and rewritten a limited number of times. Fortunately, modern SSDs use a technique called wear leveling. Instead of writing to the same memory cells repeatedly, the controller spreads data evenly across the entire drive. This prevents certain areas from wearing out too quickly and greatly extends the SSD's lifespan. Most modern SSDs are designed to last for many years of normal daily use. Many will continue working long after the average computer has been replaced. Another important feature is error correction. Tiny electrical changes can occasionally occur over time. The SSD constantly checks stored data for errors. If it detects a small mistake, it automatically corrects it before you ever notice. This helps keep your files safe and reliable. Many SSDs also include extra spare memory that replaces worn-out cells automatically. This allows the drive to continue working even after some cells eventually reach the end of their lifespan. There are also different types of SSDs. SATA SSDs connect using the older SATA interface and are already much faster than hard drives. NVMe SSDs connect directly through PCI Express lanes, allowing them to transfer data several times faster. That's why high-performance gaming PCs, professional workstations, and modern laptops often use NVMe SSDs for maximum speed. So, every time you save a photo, install a game, or download a movie, billions of tiny electronic memory cells quietly work together to store your information. The SSD controller organizes everything, protects your data, corrects errors, and makes sure your files can be found almost instantly. It's an incredible piece of engineering that most of us use every day without even thinking about it. Now you know how SSDs store your files and why they're one of the biggest reasons modern computers feel so fast. If you enjoyed learning something new today, don't forget to like this video, subscribe to the channel, and share it with someone who loves technology. Thanks for watching, and we'll see you in the next video.